We want to make flip-flops that are edge triggered rather than level triggered. Okay. So let's take an example of a very simple flip-flop. Let's take a D flip-flop. And this D flip-flop is an level triggered flip-flop. Okay. So here's the D flip-flop. It's got a D input and it's got a clock input and it's got Q and Q bar. And let's take another flip-flop just like it. So this is the second D flip-flop and you have D, clock, Q and Q bar. Okay. And what we are going to do is we are going to connect this Q to D and we have the D input. You have the clock connected here. But for the clock for the second wave, what we'll do is we'll take the clock from here, we'll invert it and give it to this particular flip-flop. Okay. And then you take the outputs here and let's call these outputs here, and let me write it in blue, Q and Q bar, and this is D, and let's just enclose all of this in one particular flip-flop, in one package. So let's say this forms a bigger flip-flop. Now let's think about how this flip-flop functions. Let me just move everything a little bit to the left. Okay. So how does this flip-flop function? Now this particular flip-flop, the first flip-flop, is going to switch on when? So if you have a clock signal like this, so let me write a clock, draw a clock here. So when is flip-flop 1 going to be on? When is it? When is the input going to influence the output? The input is going to influence the output only when we are in this high state, right? In this state, in this state. Okay. That's when D, let me just, that's when this D is going to influence this Q. Okay. What about this flip-flop? When is the output here, and let's call the output X, let's say. So when is the X going to influence Q, this Q? It's only going to influence, because you have inverted the clock, it's only going to influence this during this state, right? During this state, when the clock has become 0, because the clock has been inverted now. When this is 0, the input clock here is going to be 1, and that's when it's going to influence the things. So now let's think about what is going to happen. Let's say you have a value of D here. Okay. Now this value of D is going to influence X in this cycle, and X is going to influence Q in this cycle. Okay. Now, but once you go into this cycle, X cannot change, because X can change only when the clock is X can change only when the clock is 1, right? But uh, Q can only change when the clock is 0. So basically what happens is the change bit D can influence Q. The change gets propagated from D to Q only when you have this falling edge here, right? So when you have this negative edge, or you can also call it the falling edge, when you have this falling edge, that's when the influence of D is seen at Q. At no other point in the circuit, the input influences the output. And that's how from two level triggered gates, you can make an edge triggered gate. Let me just write that here. Edge triggered gate. And in this way, what we can do is we can stop oscillations, or things like that we saw in the previous videos that were problems with level triggering.